hopefully just not today. All right, this is going on page 71 when we're done. And so each one of my little screens will just be one of your boxes. So this is when it's closed and in your ISN like this will just be the top where we can put the title. We're going to solve rational equations and inequalities. The solving rational equations, I believe, is going to be a review for you. The inequalities, I believe, is probably not, but it's very similar to the other inequality stuff we did, so it'll be no big deal. So that doesn't take up very much in the top box, but the way I thought this out, I think we're just going to leave the rest of that top box blank. That way, if you need to go back and make yourself any little notes about what to do, what not to do, you've got a space right there to do it. Does that make sense? So if you'll go to the bottom box on the front, we are going to solve. Let's see which one to do first. So we're just going to say, I'm going to solve. We'll make this number 1. And I'm going to give you 3 over r minus 3 plus 9 equals r over r minus 3. I do. Okay, so when we solve this, is there anything we know right now that r cannot be? 3, right? R can't be 3. So maybe when we solve it, R is in our solutions. 3 is in our solution set. Maybe it isn't. But you want to have that thought before you ever start that, okay, I know for sure that R cannot be 3. Because if that's part of my answer, then that's going to be an extraneous solution that I can't use. All right? So then I need to do what? What would you like? What do you always want to do when you have fractions? Get rid of them. Right? Clear the fractions. So I have to multiply by the least common multiple of whatever the denominator is. So I could multiply each term by what? R minus 3. And remember, hopefully we're not still making this kind of mistake, every single term, right? Not just the ones that have the fractions in it. So I'm going to multiply, and I'll just rewrite this so I don't lose anybody. R minus 3 times 3 over r minus 3 plus r minus 3 times 9 equals r minus 3 times r over r minus 3. Now, would you have to absolutely rewrite everything just like that? Not necessarily. I mean, you could stick yours next to whatever it said up there. I'm okay with that. I just don't want to lose anybody. So, all right, so what happens in my first fraction? They cancel out, right? That was kind of our hope there. Are they going to cancel out here? Nothing cancels, and then it cancels here, right? So this is a pretty straightforward one. That leaves me with 3 plus, I distribute that, and I get 9r minus 27 equals r. Everybody okay with that? So then this, when I combine this, I'll get a negative 24 equals, I can move this over here, negative 8r. So what does r equal? 3, right? Okay, so r equals 3. Can r equal 3? No. So when you get something that you know can't work, because we've already decided that right here, this is called a, what kind of solution? Do y'all know the fancy word? Extraneous. So I'm going to label this as, this is an extraneous solution. And since that was the only thing I got, and that's the only thing it can't be, then my actual answer is no solution. Okay. Everybody okay with that? That was a pretty simple one to start with there. All right. If you don't have any questions, then we'll go to the inside. Do the next one then. All right. So here's example 2. We're going to solve this one. So top left box up there. That'd be good. We're going to solve this, and this is going to be 7 over k minus 3 minus 3 over k minus 4 equals 1/2. All right, so here I want to decide what my lowest common denominator is, right? So who wants to tell me what the lowest common denominator would be? K minus 3 times K minus 4 times 2. I'd go ahead and get rid of the 2 also. It's just going to make your life easier, right? I mean, you don't really have to, but hey, why not? We're doing the rest, right? So that means I'm going to multiply each one of them, and just for the sake of an example, I'm going to write it all out. So I'm going to do 2 times K minus 3 times K minus 4 times 7 over K minus 3 minus 2 times K minus 3 times K minus 4 times 3 over K minus 4 equals, and then I'm going to write a room, so I'm going to go sideways here, 2 times K minus 3 times K minus 4 times 1/2. Okay. All good? Everybody understands what we're thinking? Yes, and I wouldn't necessarily always just pick all the denominators and multiply them together. You just have to decide what the lowest common denominator is from things you know about rationals and fractions. All right, so in this first one here, the K minus 3 cancels out with the K minus 3, right? So I'm left with, and I'm just going to rewrite it not multiplied together yet so I don't lose anybody, 2 times K minus 4 times 7, right? That's what I'm left with in my first term. Minus, in my second term, what cancels out? The K minus 4, right? So that leaves me then with 2 times K minus 3 times 3. And on the other side of the equal sign, what cancels out? The 2. So this leaves me with K minus 3 times K minus 4. Oh, you know what I didn't do at the beginning? We didn't decide from the very beginning what K cannot be. So K cannot equal what? 3 or 4. Okay? K cannot be 3 or 4. So if I get either one of those as a solution, then I can't use it. We're all good with that? We understand why, right? Because this is a review? Okay, good. All right, so back down here then. I'm going to go ahead and multiply this out. So 2 times 7 is 14, so, and then I distribute that in here. So I'm going to get 14K minus, what's 14 times 4? 56. And then I can't mess up on this minus right here, right? So 2 times 3 is 6. So I get 6 times K, but that's a minus 6K. And then what? Plus 18. Everybody understands why it's plus 18, right? Okay. Equals, and we get K squared minus 7K plus 12. Everybody with me? All right. So I'm going to go ahead and combine my like terms. This is going to give me 8K, and then what is 56 minus 18? 56, negative 56 and a positive 18 is going to give me what? 38. So negative 38 equals K squared minus 7K plus 12. All right, what kind of equation do I have? What's it called? Starts with a Q. Quadratic, so what do I need to do? Set them all on the same side, set equal to 0. So I'm going to move it over here so I can keep that positive. We get 0 equals K squared minus 15K. I'm going to add that, so I get plus 15. Everybody good? So do I want to do the quadratic formula here? I would say probably not, just because the numbers are big. You can see, can I factor this? Yeah. Right, and A is 1, so that's really nice. What goes in here? Did that the other day, and then it didn't work. Okay, good. All right, so what goes in here? Minus 5 and minus 10. Good. Which means what I get then is K equals 5 and 10. Or I can write it like this. Now, can I use both of those? Yes, because I decided from the beginning that k could really be anything except for the 3 and 4. Those aren't 3 and 4, and so there's my answer. Everybody good? Yes? We can do that? All right. Do I need to do another solving rationals? Or are we good? Okay. We're going to do the next 3 boxes. They're all going to be the inequalities, because I believe that that is new to you. Have you solved rational inequalities, or do you even know? Doesn't sound familiar? I'm thinking you probably didn't. Okay, so we're going to start with a super easy one. All right, so we'll start with a super easy one. This will be example, what, 3? Yes. And so we're going to solve this. X minus 1 is x plus 1 all over x is less than 0. Actually, let's make that less than or equal to 0. Okay, so this is, remember we did this on the, for polynomials, right? Just they weren't rationals. And we had a number line type of situation that we used, okay? So you need to think about 2 things here. What your solutions are and what they can't be, right? So what can x not equal? 0. So anything that x cannot be, those go on your number line as open circles. Okay, so here at 0, this is 0. This is going to be an open circle on my number line. We're doing the sign thing just like we did before, right? Then you want to figure out what x can equal. To get that, what would you get? I mean, what are my solutions here? 1 and negative 1, right? So a negative 1 and a positive 1. So those go on my number line, just like they did before when we were doing polynomials. Oh my gosh, that would be negative. Right? And then these circles, open or closed, are determined by whatever's going on here. And since that's less than or equal to, then these are closed circles. If that was just less than, then all 3 of them would be open. Okay? So whatever x can't be, this has to be an open circle every time. Okay? Every time. Whatever x cannot be, that's your open circle. Now when we go in there and we look at our signs, again, I don't really care. I'm not really concerned with values so much as the signs, but now I have a fraction, so I got to take it into consideration for numerator and denominator. So if I pick something over here, right, I can pick negative 2. If I plug in negative 2 here, that gives me a negative, right? If I plug in negative 2 here, that gives me what? Negative. If I plug in negative 2 here, that gives me negative. So negative times negative divided by negative in the end is what? Negative overall. Everybody understand that? So then I'm going to plug in like negative 1/2. If I plug in negative 1/2 right there, that's negative. Negative 1/2 right here, what would I get? Positive over negative, which means overall it is positive. Everybody with me on that? Same idea as we did before. So then 1/2, this is going to give me negative, positive, positive. Right? So this is going to give me negative overall. Then I plug in a 2. That'll give me all 3 of them being positive. Now here's what some of you didn't do either on the test or on your homeworks when we were doing this. It's more than just this right here. You've got to actually shade the number line. And we got to decide what we want here. We want it to be less than or equal to 0. That means we are looking for the negative. So wherever it's negative, I shade it. And this should be an arrow because it keeps on going. And this is negative here. Then I also have to pull my solution off of this because it is an interval. So that means I can go from negative infinity to negative 1. I never include the infinity. Do I include the negative 1? Yes. And then I go from 0 to 1. Do I include both of those? No, because it can't be 0, but it can be 1. So you have to pay a little bit closer attention to your open and closed circles there. Well, okay with that? All right, so that's the general idea. Now let's look at one where we got to do a little bit more work to get to that, because they're not all going to be just giving you that simple. All right. Next one we'll do So this is example, what am I on, 4? Okay. So we're going to solve this. 6x minus 5 is greater than 6 over x. So in order for me to solve this, I've got to get it all on one side of the equal sign first. Okay, so let's do that. This is going to give me 6x minus 5 minus 6 over x is greater than 0. All right, so then I need to, I'm not really solving this like I did before necessarily, because that's going to affect my signs, but I need to get a common denominator here so that I can figure out what is going on in the numerator and the denominator, right? So I'm not trying to clear my fractions here. This isn't solving like we did when it was an equation. So what is my common denominator here? X. So if I get the common denominator here so that I can put all this in one fraction here, then this becomes 6x squared minus 5x minus 6 all over x. Everybody understand where everything came from? Because I got to multiply this by x over x, this by x over x. This is how I get it all in one fraction. Okay, we're all good with common denominators? Tell me if I lost you. All right, all that is greater than 0. Now for me to figure out my solutions, what am I going to need to do? Factor it. So I need to factor the numerator here. So when I do that, we can come off to the side and do that if we need to. So we get 6x squared minus 5x minus 6. So two numbers that are going to multiply to give me a negative 36. But add to give me the 5. What are they? Okay. So I get 6x squared minus 9x plus 4x minus 6. Factor out my 3. 2x minus 3. It's 2 and 2x minus 3. Right? Should be able to factor this. That's why factoring is so important, because it should be a very small part of what's going on here. 2x minus 3 times 3x plus 2. Right, so I'm going to put that back in the numerator here. 2x minus 3 times 3x plus 2. All over x is greater than 0. So now that I've gotten this far, what can x not be? 0. What are my solutions for x? That's very tempting to do plus or minus 2/3, but it's negative 2/3 and positive what? 3/2. I know. With the 2 and the 3 in there, it's easy to want to do that. Okay, everybody with me? Now that I've got what x can't be, what x can be, right? This part right here is always an open circle. This depends on the problem itself, which I can't see the original one, but it doesn't matter because I rewrote it here. So when I draw my number line, it can't be 0, so this has to be an open circle. It can be negative 2/3. Positive 3/2. Are those open circles or closed circles? Open. So in this case, all 3 open. Everybody with me? All right, so now I look at, I'll give it's a negative 2/3. I could use a negative 1 right here, right? So negative 1, if I put negative 1 in here, this gives me all negative. What happens when I put a negative 1 in here? Negative, and then negative. So overall it is negative. Everybody agree with that? Then I plug in, let's see, I could do a negative 1/2. So negative 1/2 in here is going to give me negative. Negative 1/2 in here, what would happen? Positive or negative? Negative 1/2, what's 1/2 of 3? 1.5, so it would be positive. And then this would be negative. This is positive overall. Then 3/2, well, I could use 1 right here. If I put in a positive 1, that's negative. Positive, yes? Well, I'm going to put 1. I could use 1/2 also. I couldn't use 1 here because this is less than 1, but this is more than 1. This is actually 1.5. So 1 is easier to calculate than 1/2, but either one of them will give you the same answer. I'm just going with the easier one. All right, so then this overall is negative. So since this is 1.5, I can pick 2. So 2 would give me positive, positive, positive. And since I want it to be greater than 0, that means I'm looking for something that is positive. So I'm going to shade this in here because my number line is important. I'm going to shade this with an arrow. And then I need to write my solution. So that means I can go from negative 2/3 to 0. Do I include either one of those? No. And then I go from 3/2 to infinity. There is my answer. Everybody okay with that? Any questions? Okay. All right, then last one. You have one more box, right? Let's do another one. We have to do some work. Is this example 5? So we're going to solve. And it's going to be 1 over x minus 2 is greater than or equal to 2 over 3x minus 9. So in order to do this, I first need to get it all on one side of the inequality. It's going to be much better if we always move it all over to the left. So this is going to give me 1 over x minus 2 minus 2 over 3x minus 9 is greater than or equal to 0. So remember, we're not clearing the fractions like we did before. We just need to get a common denominator. So in order to do that, this one's missing the 3x minus 9. This one's missing the x minus 2, right? So when I do that, I don't know if I need, well, I don't want to skip a step. It's okay if you skip a step, but so don't lose anybody. I'm going to do 3x minus 9 times 1 over x minus 2 minus x minus 2 times 2 over 3x minus 9. Everybody understand why I'm doing that? Oh, yeah. So actually I'm doing this is what I meant to do. X minus 2. That's technically what I'm doing. Oh, shoot, no, that's not what I'm doing. I'm multiplying by a value of 1. So I'm not changing the value of anything. That's really what's happening. I mean, you can just kind of do it and put your denominator there. You should be comfortable enough with it. Okay, everybody with me? So my new denominator is 3x minus 9 times x minus 2. And then here, this just gives me 3x minus 9. And then this is a negative, so I have to be careful. This is going to give me 2x minus 4 here, but it's really minus 2x plus 4 equal to 0. Then when I combine my like terms, I'm also going to pull this 3 out of the denominator. It'll make all the calculations a little bit easier. So 3x minus 2x is just x. Negative 9 plus 4 is minus 5 over 3 times x minus 3 times x minus 2. Greater than or equal to 0. Everybody okay with that? Should be okay. You should be good at manipulating stuff like that pretty easily, right? That's not a brand new thing. We can do those things. All right, so now that I have it all put together in one fraction there and I can see my numerator and denominator nicely, then I'm going to figure out what x can and can't be. X cannot be what? 3 or 2. So 2 and 3 is a big no-no. X can be what? 5. So when I go to my number line, I've got 2, 3, 5. Where do my open circles go? 2 and 3. Is this one opened or closed? Closed because of this right here. Yes? Everybody good? Okay. So now I go back and look at signs. If I plug in, well, I'm starting here at 2, so I can use 0. 0 is nice. I get negative. This one right here, that sign, that doesn't affect the sign at all. So negative, negative, negative. So overall, that is negative. I can plug in 2.5. It's going to give me negative. Then what? If I plug in 2.5 here, it's going to be positive or negative? Negative, and then this would be positive. So overall, that's positive. I can plug in 4. 4 minus 5 gives me negative. Plug in 4 in both of these. These are both positive. So overall, it's negative. And plug in 6. So 6 would make everything positive. And since I want it to be greater than or equal to 0, what am I looking for? Positive or negative? Positive. So then I go back and I shade everywhere it's positive. It's positive here, and it's positive here with my arrow. So that means my answer is, I can go from 2 to 3, and opened, or do I include them or not? No. And then 5 to infinity, either one of those included? 5 is included, infinity is not. Everybody okay with that? So if you could do the solution to the inequalities before, you can do this one. You just have to think in rational terms and know that sometimes you can't include things, and then those are always open circles. Okay? We good? You also might have to do a little bit more work than you did with just the polynomials to be able to get it in the format that you want. Okay? Any questions? All right, so I'm going to give you 2 different papers, and I'm going to tell you specifically which problems to do, because you're not doing all of them, so make sure you're listening so you can circle the right ones.